We
amazing
decided to make
city.
statues of ourselves.
Watch the space.
That's the 100. That's true.
You can send it to
I love that
space to
show.
build your city.
I haven't seen the last season. Is it good?
I never saw the last season.
Say debut. No? Okay, nobody got that
I've
far.
only seen like the first 6.
I've seen like 6 of them, but it's good.
All right, so we've been talking about limits, right?
Yes.
So far, you should be able to look at a graph and determine the one-sided limits to any point, including if those one-sided limits happen to be infinite, right? And then also the limits as x goes to infinity or negative infinity. And that's basically where we're at. Any questions on that stuff? So today we're just gonna clarify, it's kind of the same idea, but we're gonna clarify asymptotes and how they relate to limits. Which, if you understand what we've been doing about limits so far, this should be really basic and intuitive. But I just want to formalize it here. So basically, there's 2 types of asymptotes, right? There's vertical and horizontal. I mean, you can have a sloped diagonal asymptote. Sometimes those are called oblique asymptotes.
Oh, that's what that word means.
But we're not really concerned about those because they don't really have anything to do with limits, so to speak. So for now, we're just going to talk about vertical and horizontal asymptotes. So for vertical asymptotes, which would be either situation where x is a, this vertical asymptote is x equals a. The situation where it's going up from both sides, or you might have a situation where it's going down from both sides, like this, or you might have a situation where it's one of each, something like this, right? Those are the 3 situations. And really, technically, you could have it go to infinity from one side and then non-infinite from the other side, right? So you could have a situation like something like this, where this is x equals a. Maybe it's going infinite, and then it just picks up here and like just is not infinite. That's still an asymptote from one side, right? So how limits relate to vertical asymptotes is at least one of the one-sided limits are going to be either positive infinity or negative infinity. That's how you can tell that there's a vertical asymptote if you're just looking at limits solely, right? So for any of these situations, so for any vertical asymptote, x equals a, at least one-sided limit will be positive infinity or negative infinity. Possibly both. Maybe they'll agree, maybe they won't agree, but at least one-sided limit will have to be positive infinity or negative, right? That's the case in all of these situations. In this case, the limit itself would be positive infinity because both one-sided limits are positive infinity. In this case, the limit itself is negative infinity because both one-sided limits are negative infinity. Here, the limit does not exist, but each of the one-sided limits is infinite in its own right. And here, the limit also does not exist, but the left-hand limit is infinite. So this thing is true for each of those situations. Okay? So let's look at horizontal asymptotes and how they relate to limits. So if you have a horizontal asymptote, it's kind of a similar analysis we could take. There's several possibilities. One possibility is the horizontal asymptote is the same on the far left and the far right, right? Like you could have a function like, for example, 1 over x squared, where, or I just want to make it more of like a continuous function. So suppose this is y equals a, is the horizontal asymptote, right? So maybe the function goes like this. Maybe it approaches that value as you move to the left, and it also approaches that value as you move to the right. Or maybe it's a situation where it only approaches it from one as you go in one direction. So maybe it's like an exponential thing like that, where it's really only approaching it from one side. Or maybe you have a situation where, like an inverse tangent function, where there's two different horizontal asymptotes. Maybe it's going to one value on one side and then another value from the other side. Maybe it's something like this. This is y equals a, and this would be like y equals b. In this case, this function has two different horizontal asymptotes, right? It's not possible for a function to have more than two. That's logical, right? Because if it did, that means that on one side, at least one side, the function's approaching two different values, which would make it fail the vertical line test really bad, right? So these are basically like the three scenarios. Either the horizontal asymptote is the same on the left and right, there's a horizontal asymptote on one side but not on the other, or there's two different horizontal asymptotes, one from the left and one from the right, and they're different, okay? But in all of these situations, it's definitely true that as you take the limit as x goes to infinity, or the limit as x goes to negative infinity, in at least one of those situations, you're getting a finite number. You're getting an actual number and not infinity, right? So that's what I'll say as like a generalization here. You could say for every horizontal asymptote, x or y equals a, let's say y equals a, then the limit as x goes to positive infinity of f of x equals a, or the limit as x goes to negative infinity of f of x equals a, or both, right? That's a summary of what I just said. Either, if there's an asymptote, y equals a, horizontal line, that means either as you move to the right, you approach that value, or as you move to the left, you approach that value, or possibly both. That's that first situation, right? Where it was going to that asymptote from both, in both directions. So the Delta Math assignment tonight, let me just put it up on the screen for you so you can see what types of questions they're asking you. They're just asking you to analyze a graph for its asymptotes and then just say how that relates to its limits. Okay, so if I have, this is a typical problem from tonight's assignment. They give you a graph with some asymptotes, right? And the question says, first of all, how many total asymptotes are there? So you just count them. Well, if I look at this, there's a horizontal asymptote here, and the one down here is different. So that's two horizontal asymptotes, and you can see clearly that there's two vertical asymptotes. So I would say there's a total of 4 vertical and horizontal asymptotes. Then you just have to say what they are. So there's a horizontal asymptote. I'll start from left to right. There's a horizontal asymptote, y equals 1. So I'm going to say there's a horizontal asymptote at y equals 1. And then they're going to ask you why that is. Well, the reason why there's a horizontal asymptote is because the limit as x goes to negative infinity is 1. So there's a drop-down menu, and you can see the different choices, right? It's because the limit as x goes to negative infinity is 1. And then you just do this for each one. Let's just do the horizontal ones first. So I'll do this other horizontal one. This one is y equals negative 4. So negative 4. Because the limit as x goes to positive infinity is negative 4. Limit as x goes to positive infinity is negative 4. That's that choice. Now let's go to the vertical asymptotes. This one is x equals -1. So I'm going to say there's a vertical asymptote at x equals -1. And that's because the limit as x goes to -1 is positive infinity, right? From the left to the right, you're going to positive infinity. So the limit as x goes to -1 is infinity. That's this one. And then there's another vertical asymptote at x equals 5 in this case, right? And that's because the limit as x goes to 5 is also positive infinity, right? The limit as x goes to 5 is positive infinity. That's this choice. And then that's it. Those are the questions they're asking you. A lot of stuff there, yes, and that's it. And they give you a little picture that just shows that that's true. Okay? Some of the graphs that you'll be given maybe won't contain any asymptotes. Like this one has 2 horizontal and 1 vertical, right? Sometimes you might get one. Let's try and find one that's different. Like this one doesn't have a horizontal asymptote on the left. So this one has 1 horizontal and 2 vertical. When I was flipping through this, I saw a couple examples where it was just a random curve. Like it didn't have anything special happening. In that case, you just say there's 0 vertical and horizontal asymptotes. That would be your answer. It's just a random curve. Does everybody understand the assignment? Okay, so that's all I got. I think it's called limits and asymptotes on top of that. Okay? I'm going to stop recording here. What's that?